Okay, so what I have here, I started printing these back in 2018. These are Inmoov robot arms. If you're not familiar with Inmoov, a guy named Gail, who's a sculptor, created this robot and put all of the parts up on the web for anybody to use and to build. And there are hundreds of these robots around the world being built. And I was fascinated by the project, and I wanted to get into robotics at the time. So I just started printing these parts, and I've got pretty close to a full robot made. I've got a second and third one as well. But these were printed a long time ago. Some of these parts were rush job because I needed to get ready for a maker fair. So I needed to finish one of these hands. These fingers over here, the resolution on these prints are, this is a really quick print on these fingers. The layer height is really thick. I just cranked these things out, and I'm surprised they've lasted as long as they have. There's a crack here. I'm sure there's more cracks. Yeah, there's another crack here. These aren't very strong. There's a crack here. These would not hold up in use, really. I'm going to need to reprint all these fingers. I already started reprinting some of them for the other hand, I think. So yeah, these were a rush job back in the day when I wanted to get ready for that maker fair. Missing a piece here. I'm sure it's around somewhere. This was definitely the better hand. This was the first one. This was the first hand that I ever printed, and it's got a really, really high resolution print. This is probably 0.1 layer height. It's really smooth, super smooth. I don't know if any of these. Well, this one's broken off. This one's just missing the pin. These pins are just 3mm filament. It's just cut off to length and stuck in there for the time being. That's originally what Gail was using in these, was just 3mm filament as the hinge pivot point. These are actually in pretty decent condition. There's no real cracking, except for this one that's broken off. I think it might have gotten dropped or something, but the rest of these are actually pretty solid and could be used. So that's kind of cool. And you can definitely see the difference in the palms. This is a much higher resolution here than the one here. I was really into the military style coloring, so I wanted metal, olive green, and black. I still really like this a lot. I want to kind of keep this theme going. The fingers that the replacement fingers, I didn't have any more of the silver. I think I went to black fingers, and that's, yeah, it's thumb, index finger. Yeah, so I started printing these in black. This might not even be, yeah, this doesn't look like PLA to me. I think TG, I'm not sure what this was. Something that was a little bit more durable than the PLA. So I may end up using some of those parts when I repair the hands. As far as the arm pieces, you know, some of the prints aren't that, some are better than others. You can see this one's nice, pretty smooth. It's a pretty smooth print. But this one's not as smooth. It's got a little warping. It does have some unadhered layers, so there's some cracking. You know, I can fix it. It won't look as nice, but I could fix that up and maybe even paint it or something to reinforce that. Yeah, there was definitely some force. These things tore off. They're not clean. What I had used to glue a lot of these panels together was this acrylic adhesive. You can see it here. It's a clear acrylic adhesive. It's highly flammable. You definitely want to wear gloves when you're dealing with this stuff. You don't want this on your hands at all. It comes with like a syringe that you can kind of suck up some of the adhesive into this bottle, and then apply it where you need to, and then quickly put the parts together and hold them, and it doesn't take long. It kind of melts the two parts together. Like, it's always a good idea to kind of rough up the surfaces a little, and they will bond really, really well. I don't know if you can see in there. It's really rough when it's separated. A lot of these parts are still really in good shape. This filament line that I used for the tendons in the robot is really good, heavy-duty stuff. It's this heavy-duty fishing line. It's braided fishing line, 200-pound, 0.75 millimeter. It's not going to stretch. It doesn't stretch at all. It's really good stuff. And I've got more than I could ever need on just one spool. So it looks like I can clean up these panels. Most of these panels are going to be fine. That's what's really cool. The body of this thing has really held up well. I think that's edge of this is a little rough. See that, but that's all right. Functionally, it's going to be fine. That's kind of what I'm worried about. Is finding all the flaws. Yeah, as you can see, I glued this silver piece to this black piece of PLA, and the only thing adhering it to that is this acrylic adhesive, and it's nice and solid. It's not going anywhere. It's really good stuff. And some people use turn this down a little. Some people use super glue and some different other things. You know, I found that stuff to be very reliable and strong. This acrylic adhesive works really, really well. And I'm sticking with that. All right, so what I think I'm going to do, I'm going to go ahead and keep the right hand up here. This is what I started with. The first one I ever did. I'm going to keep this one centered. I'm going to take this left hand and put it aside for right now. I might bring it back in a few minutes, but I want a little bit of room. Oh, look what I got sitting here. Little side note. I started printing the new Inmoov hand. These hands, all the motors that run the fingers are actually in the forearm. They're located in that. The new hand, the new style, has all of the servos located in the actual palm in each one of the dots, and then the fingers attach right here. So they don't have as long of a path to pull, because when you've got your motors way back in the forearm and they've got to drive the fingers that are way up here, there's a lot of friction points along the way, and there's more possibility for slack, and you got to add springs to kind of keep everything taut, and there's just the longer it is, the more things it has to pass by, the more problems you're going to have with those controlling lines. So this is a really good idea. I can't wait to finish the rest of this printing so I can try it out. This is going to be a cool hand, and I'll definitely show that when I've got all the parts printed. I printed a few other parts for it. I didn't like the quality of the parts. I've got to figure out a better way to print them out, and then I'll add those, and I'll have a video of me assembling this hand once I've got all the parts. So put that aside. Here's the bicep. This screw here is your bicep muscle, and this servo is trashed. You can hear the gears are stripped out in it. I got to get a new one in here, and it'll drive the bicep for the arm. I'm going to go ahead. This is the elbow here. Let's see. This elbow. There, inside behind this gear, goes this potentiometer here, and this is what determines what angle that so it knows what position the arm is. So this gets attached behind here and it's hooked to this gear. So as this gear moves, a little gear, it will turn this potentiometer, and the different resistance that it displays will correlate the angle. So that's how that works. We're going to set this aside. All right, I'm going to deal with this hand here. Okay, this is definitely broken there. I'm going to untie this. I think I'm going to try and repair this. I think I have pinky down here that's printed. Yeah, I forgot about these. These are really tough. These were a different style printer. Here, I've got one here. Instead of using the tendon wires, another design someone came up with was using flexible filament, which is what the orange is here, and then the black is I think I don't think this is PLA. It looks like a PTG or something. I don't know. But anyway, it could be any non-flexible filament, and the finger will bend like this. So basically, all you're worrying about is pulling the finger, and then it would retract. So, but this one takes a lot of force. I think to make this work, these have to be much less dense. I think when I printed these, I was just starting out with flexible filament, and I had the infill on the inside way too high, and they take a good amount of force to bend, and it really would be, I'd have to have a lot of force to bend those. So it's a cool idea, and I still I think I want to make a hand that uses this just to try out all the different ways of going about making a robot hand. But I would definitely have to reprint everything and make the infill on this TPU a lot less. So let's see. Here's some of the parts. This is the part I need to replace here. Let's move it over. So this part is actually this piece here. It would go like that. And the other half of it looks like it's this. So yeah, like that. So that would need to be glued together. I guess I could find out if it's PLA right now by trying to glue this together using the stuff I have. Alright, so what we'll do, I'll go ahead and do that. Alright, let me grab some. Alright. Grab something to work on, probably like this. Alright. So this is the joint that needs to be replaced. This is what needs to be sanded, glued together. Hello, hello, who's there? Someone has joined me. Again, this is the adhesive I would use. It's acrylic adhesive. I use that on all different PLA. It's fantastic. This is the Inmoov hand. This is my original one I printed back in 2018. It's got quite a bit of damage, but I think it's definitely able to be repaired. I've taken it to maker fairs, to hacker spaces, and it's with the rest of the robot, and it has survived for quite a while, but it needs to be redone. So this piece here would be the new piece for right here. It's this part's broken off. I'm going to go ahead and take this tendon out. This is our first live stream on the channel. We'll do these for working on different specific parts when we've got specific jobs to be done. It would be really boring if we did it on our normal working nights, because a lot of times people are just staring at screens working on code and stuff, and it's like that would be pretty dull. But when I get a specific job like this, then it'd be worth doing. All right, take this out. Take out this 3mm pin, and this is our broken piece. You can see this is what needs to be fixed. I need to grab an emery board or something to do some sanding. I don't see any. Look here. Maybe some sandpaper. Aha. This one's pretty beat up, but it'll work. All right, so just the idea is to get this surface roughed up a bit, just so that it's got some loose edge. And then I'm going to get some gloves on here because I don't want to get this stuff on my fingers. It's on my fingers. It is not. Where are we at? Trying to use one of these gloves. All right. So, what I want to do, get this. I'm going to get some, like this, paper towels. They have registration marks printed on these, so you can line these up pretty well, which is helpful for sure. Oh, there's stuff in here I gotta clear out still. Just little bits of filament still. Rough spots. There we go. I don't want to have to do that after the fact. Clean out anything that's going to get in the way of movement of those fishing line tendons. All right. That's the way it's going to go. Just like that. So, very little of this left. Let's see if I can get away with it without ordering more. Oh yeah, it's pretty gross too. Oh, it's kind of corroded the inside of that can. All right, we're gonna get just enough out of here for the job. Tiny bit in that bottle. We don't need more than that. I'm going to put it on here. Oh, it looks like I'm going to need more than that. All right, we're going to do it a little bit unconventional here. Just because everything is so low. I don't typically pour this stuff, but there we go. And it's normally clear. The reason why it has some color is because it's kind of taken on a little of the rust that's inside of that can. That's an old can of that stuff. Alright, so alright. Basically all I do is wet the surface that I'm going to adhere on both sides, and then stick it together as quick as I can. Making sure I've got my registration lines marked, lined up. And that's pretty much it. Just give it a little bit of pressure. Hold it. It doesn't take long at all with this stuff. It's pretty much together. I am going to do something along that. It's not an exact match. But, oh, there we go. It's good. We can move it a little bit while it's still kind of molten. Help the two together. Alright. That should be pretty much good. This stuff evaporates so quickly. Two pieces or one. And that's that. It'll be ready here really shortly. It'll be done. So that was the replacement for this right here, this joint. Just like that. It should fit right on there. It's not super smooth, so I'll sand it down and sand the what's going on. Sand that down. Emery board is really good for that. It doesn't take a whole lot as long as it's been printed well. I printed these probably almost like a year ago to replace this, and I just didn't get around to it. So they should be very smooth, just like that. This one's a little tight still, so That's the other thing I need to do is drill out those holes so they're big enough to receive this. So, that's about the same diameter. That looks good. Actually, looks like it. All right. I do it all the way through like this, just so I know that it's lined up, and that filament's gonna line up just right, just like that. Feed these through. Little bits. So for now, the smaller end of the bit. Let's see which fits better. It looks like it should go that way, but it's tighter that way. Yeah, that is right. Wanted to make sure. That's going to be tricky going through there. Huh. Yeah, I got to get that filament back through those tiny little holes. That's hilarious. It frays at the end. Have to trim it down. So, let's see, this is the upper one. Let's look the lower one. You gotta make sure that we keep it straight. That's right, I didn't drill this out. Top one, lower one. It would be the compression, and it would be the retraction. Oh. Lined up. These pieces of filament are a little bit bent. Yeah, there we go. So that was the piece that was broken. So, like that. So actually it's like this. So that's a good replacement. I'm not worried that it's black and the rest is silver. I think over time he's going to have a lot of different upgrades and changes, and I'm not really concerned with keeping him in a really uniform color scheme. He started out that way, and that's really cool. I think it'll be cool over time to see him change and grow and be different. So I'm not real worried about it. Let's cut it like this. Good. Not bad. Not bad. What time is it? All right, we're at the 45-minute mark. I was going to stop at a half an hour, but I kind of got into this repair, so I'm just going to go ahead and finish this little repair part here, and then call it a night. Live streaming. There we go. There. Go through. Yep. Alright. Alright. Do I have another pin? Oh, I think I've got some extras in here though. Oh, that's too small. I need some 3. I used it. Let me see if I have some here. If not, I can find some for sure. There's a short piece. See, and each of these fingers has a fingertip as well. Once I've got everything nailed down, I can put these fingertips on. I just haven't. Yeah, I never got that far, and I didn't have it down to where I was super satisfied with the movement. So just never got there. But that's I've made a mess in my workspace. Oh, here's a pin here. Use this. Yeah. So now we've got this finger repaired and moving good. It could move a little bit smoother, so I might take it apart and file these down a bit more, so that I want them to move completely smoothly. I don't want there to be, see how it stays in place. I want it to just flop back into place. I don't want there to be really any friction on these. So I'm not going to tie this yet, because I'm probably going to go back and take this, like I said, take it apart and file everything. But, yeah, just a quick little repair. Next time I might be working on these hands, the arms. I might actually be working on the head too. I've got to get the eye camera mechanism working smoothly and get his head back together. You can see him in the thumbnail when his head was assembled. Right now it's totally disassembled. It's not even on his body at all, because I was working on the eye assembly, which let me grab that. Oh, this is what I was working on. Maybe I'll work on this thing next time, and then I'll get the head back together. It's got two cameras, one in each eye, and they just plug in USB. They are the camera boards out of a couple webcams, so they're not the greatest resolution, but they definitely do the job. And when I had him assembled before, he was doing really good face tracking, but I wanted to redo his neck because there were some joints that weren't as smooth as I'd like, so he's moving really smoothly now. So I want to get this mechanism tightened back up and back into the head. So maybe next time I'll do that, or I may continue working on the hand. It just kind of depends on what I have time to work on. But I'm definitely going to be streaming more. So if you see this stream after the fact and you want to see more, I'm sure I'll get better at it. This was the first time. And that's pretty much it for tonight. But we got one small thing done. These have been sitting on a shelf for a while. So we're going to need some work. But it's pretty cool. It's pretty cool. You can make robots in your garage, in your house, in your workshop, at home. And these aren't the most durable ones, but what they'll do is they'll teach you how to make ones that are, and the next ones we're planning to make are going to be made of aluminum. So we're going to step up to aluminum and make parts out of that. It's fairly easy to work with. But we're still working on these. We'll get there. So until next time.
Take care.